first session's video again too, and I don't know what happened to it, but I would like to have, or not video, but presentation, so I could have both sessions.
Yes.
Thank you.
All right, working on it right now. Okay, let me open the chat. And okay, so that one's today, and let me find the previous ones real quick. Okay, and here comes yesterday's. Anyone can view. Okay, copy. I lost. There it is. I have too many tabs open. I lost track of where I was. Okay, so here's yesterday's. And just for fun, I'll do here's Wednesday's presentation.
Thank you. Thank you very much.
No problem.
I saw that Brianna was in here. Brianna, hi. I'm Reno Mata, and I got an email from you. I was just wondering if you got my email response to your, I think something about me not signing up for my Wednesday, and I thought I did. So I was doing the curriculum instruction with Leticia and Carolyn Wormley. So if you didn't get it, please let me know.
All right, let's go ahead and do quick introductions again. Just in case we have anybody new here. I know some of us were here before, but just a nice way to get started.
I'm Maria Cano, and I teach at Carlake Community Day School, which is part of our district. I teach grades 7 through 12.
Awesome. What do you teach?
All subjects.
Oh, all subjects. Cool.
Self-contained, expelled students.
Oh, okay.
Maria, where is this again?
It's at Carlake, which we're located.
Okay,
it's only
yeah.
2 classrooms. And right in front of Mount Toro.
Awesome.
Yeah.
Thanks for joining us.
You probably get some of my students.
I get all of your students, everybody's students.
Maria, just a little bit about Erne. Erne is a little special, so you may have to send him a map or something so that he knows exactly what you're talking about, because he's just special. I like Erne.
Ernesto, I don't think you want to come to my neck of the woods, but I can send you a map.
Actually, Maria, because of your program, that's their last step, so they have to behave.
Well, they don't. You should see the fights that we have every day.
Nothing different to what I have.
Oh, we have daily rumbles over here.
Daily rumbles.
Hi, Stephen.
Hello.
I guess I'll go ahead and introduce myself. My name is not Erne. My name is Ramiro, and I teach at Allison High School. I teach all math, and I've been in Williams actually before this COVID thing, and I thought it was cool. William does some amazing. I wish I had his talent, because he does some amazing things with motherboards and robotics and things that can really
I'm gonna call you back.
help you at home. I love that fact that he was able, show us that little garage opener. It was amazing. Had I picked up on that, I'd be having no problems with my garage right now.
Yeah.
Thank you,
Well,
William.
I'll share the circuit of the solid state relay circuit with you. It's not really talent; it's just persistence more than anything.
Ernesto Mendoza at LSL High. I teach math 1A, 9th grade.
I'm Stephen Likin. I teach at Alice Salazar. It looks like it's all Alice Salazar by school. I teach Math 1A and Math 1B.
Nice.
And I'm Jennifer Westerbeck, and another LSL High teacher. Yay, team. We're like totally interested in our technology here.
Hooray.
Engineering Academy.
Awesome. LSL's the best.
Yay!
Scott Rose here. I'm at Alvarez. To break it up a bit, I teach film, graphic design, photography, and I'm part of the Digital Media Art Academy.
Oh, hi Scott. I watched your workshop yesterday.
Oh, cool.
Yeah, thank you for doing that. You got me thinking a little more seriously about how I approach video and the fact that I should really be planning things out better than I have in the past. So
yeah, I really wanted to focus on the planning part because a lot of people don't think about it that much. But when you teach a class, you plan it. You create your lesson plan. You create your agenda and your objective. And you want to make same thing with the video. You want to make sure that you've done that beforehand, or else you don't know what's going on, what you're doing.
exactly. I'm going to try to start doing more pre-planning.
All right, awesome. Let me know if you have questions. You can always email me.
Yeah. Okay. Thank you.
Awesome.
Okay. Is that all of us? All right. Well, as you might probably know, I'm Bill Thompson. I teach ceramics at Salinas High School, but I like coding and robotics and things. So I've been teaching these coding workshops for a while. Before we get started, I just want to mention something that I found just recently that that might help you if you're teaching something where you need to show students things. I had trouble in the past when I'd be trying to show people stuff and I'd be like, "Can you see that?" And then I downloaded an app to my phone called WebIP, and so now instead I can. Oh wait, it's not live. Darn. Okay, there we go. So let's see.
William, let me interrupt the sign-in.
Yeah. Oh, I'll put it on in the link. So anyhow, this is WebIP. So now instead of trying to hold something up in front of my computer camera, I can use my phone to stream video to my browser, and so that way. So this is going to be, for me as a ceramics teacher, this is going to be pretty important in a couple of weeks because I'll be able to show people how to do things with my hands, in a better way than trying to hold it up to the camera on my Chromebook.
Bill, can you show us your screen?
Oh yeah, sorry. Let me. I've got so many tabs open. I keep. Show screen. Okay. So. All right, there we go. And let me get rid of this one. That's an old one. So this is using the using my phone as a webcam. Basically, I have a little stand to hold it up, and so that's going to be a lot easier for me to have something pointing at the tabletop instead of trying to hold things in front of the camera on the computer. So that's called WebIP. Let me go back to. Okay, I'm gonna go back to.
We should have that, like while we're solving problems, we should have that tool or something, like to show in a paper or something.
Yeah, that'll be that's my replacement for a document cam, basically.
Because that was pretty clear.
Yeah,
the document camera would blur, would reflect some light. I don't know.
Yeah, I'd asked my wife. I knew she probably had like a webcam sitting around, and I asked her if she could find a webcam for me, and she found one. I think it was kind of a little bit on the old side, and I hooked it up, and the image quality on it was very poor. So the image from my camera, the phone on my camera is much better quality. Okay, so there's the sign in for today's session. Go ahead and take a moment to sign in now to make sure you don't forget.
I noticed that on the first day, Wednesday, when I signed in for my presentation here, I had to go through what I did right now, which is type in exactly what, in other words, the form was not pre-done. And so
Oh,
I did that and I submitted it. And then I got an email from Brianna. That's why I was talking to Brianna because I thought I seen her here. She's saying that I didn't do it properly or something like that. And then right now, when I went to Bitly, it's not, I have to sign it again. It's not pre done for us. And yesterday's meeting, it was. So I don't know if I'm going to get another email from Brianna saying that I wasn't there or maybe something along that line.
huh. That's strange. I don't know why, because I'm pretty sure I used the link she gave me, but
Okay,
I
excellent.
can.
Quick question: is this
Yes.
2-hour workshop or
Yes.
3?
Yeah, this is 2 hours.
And
Wait, 2
my
or
school
3?
isn't coming up.
Your school's not coming up.
No.
That's
Sorry.
you might have to email Brianna and let her know.
It's part of the redheaded stepchild syndrome, but that's fine.
Yeah, I used to be a redhead, so I understand that pretty well.
Will,
I've gotten older, my hair has turned brown.
did I hear 2 or 3?
2 hours.
2. Okay.
Yeah, all the sessions are 2 hours.
Thank you.
Maria,
Let me see if I can find the original link that Brianna sent me, just in case I had made a mistake as I created the Bitly.
no, you're fine. I just did it again and it worked this time around. So I think that's okay. So if
Okay,
Brianna
good.
can't find her school, that's because she probably talked to Erne. Erne is just bad news.
Herme, I'm not sure I know who that is.
He's here, Ernesto.
Oh, okay.
No, we're always excluded, but that's fine.
No, it's not, but but we'll have to just be persistent and make sure that they take care of you. Yeah, I always like to try to make sure everybody's remembered. Okay, so yeah.
Sorry to cut you off. Can you
No, that's
share
okay.
once again the presentation for today? I didn't see that one.
It should be the first one in the chat.
I think I came in a little bit late, so I don't see some of the chat.
I'll share it with you. I'll copy and
Thank you.
paste.
Thank you so much.
Okay, and since Maria's new here, I'll just real quickly go over some of the stuff I've gone over a couple times now. So, but I'll try to do it faster each time. So bear with me. But I do like to kind of tell people why I do this. And
Oh no, that's okay. I took your Wednesday class or workshop.
oh, okay. So I think everybody here, I've already talked to you about that stuff before. So I'll skip that part of the presentation. And I'm just curious. Yeah, somebody's. I was wondering if I was recording or not, but somebody started recording for me like each time, so that's pretty nice. They know that I'm the kind of person who would forget probably. Okay, so let me find my way to the presentation. That was yesterday. I'll close these out so that it's less confusing. All right, so today what I want to focus on is a device called a Microbit, which I told you a little bit about in previous sessions. But today I want us to actually use the resource, and in particular, we'll use the online Microbit simulator for those of you who don't have one. I know 3 or 4 of you, I think, have a microbit in your possession, and I'll be showing you how to hook it up and things like that. I also want to show you a resource that I found just this morning that I'm pretty excited about. So what I'd like you to do to start with is go to your search browser and just type in makecode.com, and that should bring you to this website here. And I'm not watching the chat, but it's helpful if you could just give a shout out once you're here. Let me know, and I'll know we're all in the same spot. Okay, I went back to chat. Let's see, Stephen, are you there? Are you okay, Stephen? Okay. Jonathan's ready. Okay, Stephen's ready.
So it should say hands-on education. Is that what it should say?
Yes.
Okay.
Okay,
Yeah,
you
I'm
got
there.
it. So you're there. And so in a minute we're going to click on the microbit, which is where we'll kind of spend most of our time today. But I want to show you some of the other things that are here. This is another physical device that can be programmed. It's a little bit like a microbit but different. I don't have one of those, but they can be purchased through this company called Adafruit. And they have Minecraft in here, but I don't know. When I looked at it, I was a little disappointed that it involved a download, and I don't know. I'm not even sure. It seemed like you'd have to buy something, so I was kind of bummed about that. But here's the one I found today that I'm kind of excited about, and I was hoping the teacher from Washington Middle School was going to be here today because she was looking for things for people to do at home. It sounded like she was really going to enjoy Scratch, and this is kind of similar. So this is a block style editor for making simple little games, and I only played with it for an hour or so, but here let me see if I can find like a game, like a sample game to show you on here. I played so there's some lessons in here. There's tutorials to show you how to do it, which is what I did. I just looked at an initial tutorial, and so here I'll just click on one of the games that's already in here to show you an example of the kind of thing that you can easily make using this. So here's one sample game real quick, and then I'll show you the interface. So a bit like Scratch, when we looked at it, there's a palette of commands, and that you can go through for creating your game, and then there's this workspace for creating the game on. And in the virtual controller, you can control it. You can use the virtual joystick or the keys. Hit the A button to fire, and so this is kind of like an asteroids game. Okay, and that was me dying in the game. And then to the left, this is the block code that created the game, and so it's not real complicated. I'm gonna go back to home. So so I just want to kind of put this on the map for you, and I want to point out that there's some simple tutorials here to kind of step you through what the different block commands do, and I think this might be a fun thing for students to do that they can kind of do on their own. That'll get them used to coding and programming structure. Okay, so I'll close this out. All right, and then we're going to go into the we're going to double click on the icon that looks like a microbit. And so this is this is the initial screen you'll come to. Before I click on new project and go into the programming environment for programming a microbit or using the microbit simulator, I again want to point out what else is here. And for some reason, okay, there we go. There's some lag in my computer. I probably should close tabs out. So again, I want to point out that there's lots of tutorials here to kind of step through and help you learn how to use this device better. I also noticed they started having live coding sessions as like an educational thing since the pandemic started. They have some sample games that involve the radio. There's also some science projects here. I've done the soil moisture measuring one, but I noticed there's timing gates to accurately measure like the speed of a moving object. So I'd like to try that. I thought that was pretty cool. And there's courses in here with like more instruction and stuff. So there's a lot of resources here. So if you start playing with it later and you don't remember how to do something, just remember there's a lot of learning resources here on this page. Okay, so I'm going to click on new project. Oh, it's making me give it a name. It didn't used to do that. Okay, Bill's test. All right, so this is the programming environment for the microbit. On the left, we have a microbit simulator. So that'll run our code and kind of show us what it would do, even without programming a microbit physically. So if you don't have a microbit, you can see what your coding would do on this. And then if you do have a microbit, I'm gonna show you how to plug it in and actually program it. I like devices that are physical and interact with the environment, that can be coded and can collect information from the outside world or do things in the outside world. So that's part of why I'm excited about this particular product. Now, most computer programs have basically three different elements to them. They have instructions that are executed when the program first starts and just get executed once. Those go under the on start block. And then usually a computer program will drop into a loop where it just goes through and repeats instructions over and over again. The other main element of computer programming is blocks of instructions that are executed when an event occurs. For example, pushing one of the buttons on the microbit would be an event. So I want us to quickly create our first program. And to do that, we're going to use some programming blocks from the basic category. So if you click on one of the categories in this palette section, you'll get a selection here, and you may notice a more button. I don't see one here. At any rate, the show LEDs will display on the screen of the microbit, so it can display numbers or little pictures and things. And when I start a program, I like to start it out with the smiley face because coding makes me happy. And then notice the smiley face is showing up in the simulator. The other reason why I like to put a little face or something on the start block is so when I plug it in, I'll know that it's been programmed instead of just looking at a blank screen and kind of wondering if it's doing anything. And
sorry, when I try making the happy face, mine turned into a somewhat of a gray color.
Okay, I can explain that. If your happy face is not connected to anything, then the code for it won't execute. So you'll need to drag it over until it lines up with the on start block and drop it, and then it should turn blue.
Roger that.
Okay. So in my program, it's going to show this happy face when it starts. And then in the forever block, I'm going to drag out a different happy face, a wide-eyed happy face, because feeling like I know what's going on now. And I'm going to add an event to my program also. So I'm going to go to the input section. I'm going to select on button pressed. So this is a button A pressed. And when button A is pressed, I'm going to display a message. So I'll grab the show string, and I'm going to change my message to love microbits. Okay, so there's my message.
On button A.
Yeah, that's over here under input.
Okay, thank you. I didn't know you could hear me.
Oh, I'm glad I can. Drink a little tea. Now, if you physically have a microbit with you, it should have come with a little USB cable. And go ahead and plug your microbit into the computer. I'll show you. I'll show you me plugging mine in. By the way, your microbit probably looks like this right now. It came probably with a battery pack. You don't need the battery pack while it's plugged in, but once it's programmed, it'll hold the program that you put into it, and you can unplug it from the computer at that point, and it'll still execute that program. And if you're doing that, then you would need to plug in the battery pack. Okay, so here I'm gonna get my computer to where I can see it. There we go. So I'll take my USB, plugging into the computer. This one, I may already have a program in it, I'm not sure. And this is the point of constant annoyance with me. I got to get rid of Dropbox because every time I plug in a USB device, it wants to know if I'm going to upload some photos.
I plug it in, and there's the red colors and the yellow one at the back.
All right, so the red colors, if it's lighting up on the front, it just means it's already been programmed, and so it's just running a program that was already in it.
It's blinking.
Okay, so it's just running a program that was already there.
Okay.
All right, so now now that we have it plugged in, I'm going to come back
There's a question. Where can we buy a microbit?
That's
Maria.
a great question. There's basically 2 U.S. distributors. There may be more, but there's 2 that I've used. One is named Adafruit. They're back in New York, so it takes a little longer to mail stuff. And the other one's name is SparkFun. And here, Adafruit, I'm going to put it in the chat bar also. So those are 2 U.S. distributors for microbits.
Do you know if they'll accept one of our POs?
Yeah, they will. They do accept POs, and I've organized orders through them before, so there's like a process to go through before that can happen, and that process has already happened. So they're primed and ready to accept orders from our district.
Perfect. Thank you.
Yeah, I kind of prefer SparkFun to Adafruit in that they get shipped here a little faster, and I think their prices are a little bit cheaper. But Adafruit, I kind of admire like their website because they have a lot of instructional videos, and they have a good forum on the website. Adafruit also has something pretty cool that's a little tricky to figure out called Adafruit.io. And so they allow devices to communicate through the internet, and so if you have an internet-ready device, that's a neat way to go. But by the way, Jennifer, something else I wanted to mention. Here, let me go back and try to find on that arcade game thing that I just showed you. Just like we can program our programs into Microbit, the arcade programs can be programmed into a variety of different devices. And one of those devices is a Raspberry Pi Zero, which is kind of a stripped down, extra small version of a Raspberry Pi computer. And a Raspberry Pi Zero only costs $5, $10 for one with Wi-Fi. You still need to get an SD card for it, and you'll still need an adapter to plug it into, an HDMI and hook it up to keyboard and mouse and things to use it. But They had on the website, they have some instructions on how to hook up a Raspberry Pi Zero and set it up for arcade games, including like, wiring buttons and things to a cardboard box. And it just struck me as a good little engineering project.
Yeah, that sounds good. So the other one that you suggested was Raspberry Pi 4?
Yeah,
right?
that's a full Raspberry Pi. That's $35 more if you want to get it with extra RAM and bring it up to being on par with a desktop computer.
Got it.
Okay, so if you have a Microbit plugged in, I want to show you real quick how to physically program this into your Microbit. If you're just running the simulator, or just if you're feeling impatient to see your program running, notice if you click on the A button, it should show your message. So there's a simulation running of the program I have written. Okay, but what I'm going to do now to actually put this into my Microbit is I'm going to hit the download button. Here it basically gives you some instructions about finding it in your download folder and dragging it. I'm just going to close that. And then different computers are different, but for me, I right-click and then I show in folder to see my download folder. And then here's the Microbit build test. And you can see here's a Microbit on my showing up as a USB device. And I just drag that file and drop it on the Microbit. And now it's programming. While it programs, you'll notice that the light on your Microbit will be flashing. And so now my Microbit's programmed, and so here it is. There's a reset button on the back of the Microbit, just like unplugging it. So there it's showing the face and then the other face. And when I hit the button, oops, I hit hit the reset button on the back, and now it's scrolling my message on my actual Microbit that I have in front of me.
Wait, sorry, can you go back and see how it's reset, and then how do you do the transfer to the physical Microbit?
How to program the physical Microbit?
Yeah, like how do you reset this? Because I think there's already a program attached.
So we gotta put your program in the Microbit. Yeah.
Okay.
Okay. So here's what I had to do again. I'll reprogram it, and in fact, I want to fix it because there's a aspect of my program I'm not satisfied with, which is my first happy face only flashed on the screen and immediately went to the second happy face, and I want to stare and admire my initial happy face for a little longer. So I'm going to use another block statement called a pause statement. I'm going to click that in place. Instead of pausing for 100 milliseconds, which is 1/10 of a second, I'm going to pause for 2 seconds before it switches faces. And I'm going to call this build test B now. If you use the same name, it'll just repeat it and it'll put a 1 or a 2 after it, depending on how many times you've reused the same name. And then I hit the download button. So you can see that, right?
Yes.
Okay. And now it's downloading the program into my computer. You'll find it wherever your downloads folder is. Depending on your computer, that you might do that differently. But for me, I just right-click the bar at the bottom of the screen where it shows that it downloaded, and then show in folder. Here's build test B. As a USB drive, I see the Microbit over here, and I just click on my file and drag it over, and then drop it onto the USB drive labeled Microbit. And so right now, there it is programming. Oh, you can see the blinking light, still programming. And now there's a happy face staying for 2 seconds. Changed happy faces. My annoying Dropbox showed up again. And now I can hit the button and I should get my message.
Okay, I'm sorry. Can you go over it again?
No apologies necessary. I'm used to going things over again because I'm a high school teacher. Yeah. So I'll go back here.
The blinking is the part that it's right here. Hooray! Look at this. I'm so
So I don't need to pair the device.
You don't need to pair the device. You can basically kind of ignore what it says on the window here. Well,
Okay.
locate, download hex file, and drag and drop on the Microbit drive. I mean, those are your instructions. But you don't have to
Okay.
do anything here.
Okay.
Basically, do you see a spot where it downloaded down here on your screen, where my
Yes.
mouse is hovering?
Yes. Yes.
And are you using a PC or a Mac?
PC.
Okay, so if you right click on that, you should be able to hit show in folder.
Show in folder. Okay.
Click
Yes.
on that.
Right.
And now highlighted, you should see the file that you created. That's your
Yes.
program.
Okay.
And where you see your drives, you should see a drive labeled Microbit. Mine says Microbit D. Your drive might show up as a different letter.
It should just be Microbit. Yeah.
Okay, so you click on the file that you want to load into the Microbit and drag it over to the drive, and then release it, and then it should start programming your Microbit.
Okay. So that's all right. So I'm dragging to. I guess that's where I didn't get it. Drag to the Microbit itself.
Yeah,
Got it.
and then let go of the button and drop it there, and then it should start
Okay.
programming.
Okay.
It's fun.
It's doing it.
Fun.
All right.
William,
Yeah.
could you show the button A power again?
Say that again.
How do you activate the power on button? The A.
The A button displays the message. It powers on just when you hook up power, when you plug it in. And you can either activate it if you have a Microbit by hitting the button A on your Microbit, which is the left button. If you're using the simulator, you can press on the button here on the screen.
I was pressing on the A directly. Oh.
And I'm sorry, your audio got cut off in mid-sentence, so I didn't hear what you said.
I was pressing exactly on the letter A.
Oh, you're pressing here on the letter A? Oh, I get it. You're pushing here instead of on the button.
Yeah, correct.
Got it. Let's see. So, is anybody stuck at this point?
I'm good.
Good. I'm good.
Okay.
Good.
Okay.
Good.
Okay. 4 people are good. That's that's pretty good. 4 out of 8. That's passing, right?
In the physics class, yes, that is
Yes.
passing.
Yeah, if it's a curve. Yeah. All right. So I'll switch back over to here. Let's. So I want to look at some of the other things that we can do, and and then I want to maybe like go into some like programming type concepts. So here, first thing I want you to notice is there's a programming A on button A pressed, but there's no on button B pressed here. So if I want to display a different message when I press button B, what I do is I have to click on that arrow and then select the B. So clicking here creates a drop-down menu. I can also have an event if I press both buttons. So I might show a different message, or maybe I'll show like an LED pattern Usually I'd get us like blinking LED circuits because I like hooking up physical circuits, and I can't right now, so I'm gonna blink. I'm gonna do some blinking on my screen here, and then that'll also be a good way to segue into another programming concept I want to talk about. So just like when I first programmed it and my initial face only flashed on the screen for an instant, if I blink this on and off, but I don't put a pause in between the two, then it won't stay very long. And another thing I wanted to show you was if I right click on a block, I have a duplicate command, and that'll duplicate it. So like if I want to change my blinking, I don't need to redraw out that pattern every time. I can just duplicate and repeat that pattern. So here we go. Here, I'll do this one again. So I'm going to blink this on and off twice. I'm going to let them stay on for a second each. I prefer fast blinking, but since I don't have it blinking very many times here, I'll go. Oh wait. Oh, here we go. Pause a second. All right. So there's my B button. It's gonna blink through that pattern twice. And I could download this again and load it in a Microbit, but remember I can also look at this on my simulator.
William, let me interrupt. My B is not working.
Your B button?
Yeah.
Did you click on the arrow here to change it over to B?
Yes, I did.
And are you hitting the button on your Microbit or on the screen?
On the screen. Oh, you know what? Yeah, it worked. It worked.
Okay. So there's a funny little glitch in the Microbit that we're gonna see here as we hit this. See how it's putting the face on the screen in between blinks?
Mm-hmm.
I don't have the face in here, and that's kind of a slightly tricky thing, but it also illustrates a good opportunity to talk about another programming concept. So what's happening is as I execute my event in the background, the forever loop is still running, and it's interrupting my event, and that's very disconcerting. So this is a good time to learn some other programming concepts. So necessity being the mother of invention and all that. So we're going to create something called a flag. Here's a flag. So I'm going to go down to variables. I'm going to make a variable. I'm going to call the variable I'm going to call it my flag. I have a variable called a flag, and I'm going to set the flag to 0, and I'm going to go down to logic, and I'm going to use an if-then statement, and I'm going to put my smiley face in the if-then statement. I'm going to also go back to logic, and I'm going to select a comparative statement and go to variables, and I'm going to put the flag in here, and I'm going to put this into my if-then statement. Now what an if-then statement does is it will execute the code inside after the then if the statement after the if is true. So it comes here, and if flag is equal to 0, it'll show the happy face. Okay, and the variable flag is equal to 0 because I set it to 0 to start with. Now what I'm going to do when I enter the B loop, I'm going to go back to variables. I'm going to set flag to a number that's not 0, say 1. Now, as soon as it hits the B loop, flag turns to 1. And even though the forever loop's trying to run in the background, it'll say, wait, flag's not 0, so I'm not going to do anything. And because I want my happy face to come back after I do whatever's in B, at the end of my loop, here, I'm going to copy this. After I'm done doing the things I want to do in my interrupt, or in my B button section, I'm going to go back and I'm going to set my flag back to 0. All right. And I can load this into my Microbit, but also I can try hitting the, see if their simulator's up to the task here. Yes. And now my intended code is running without the interrupted happy face in the middle.
So it's confusing to me. So we started with the 2 happy faces, and they don't have to be connected, and it ran both of them. Then you added more code. I just assumed connected or not connected, as long as it was going to be on your palette there, that it was going to run. And so, and you called it more of a hiccup. Is that, I just figured anything that's on there, whether it's connected or not, is going to run.
Well, different things run at different times, and maybe calling it a hiccup or a glitch isn't really the right term, because there may be times when we want code to be executing in the forever loop as it's executing code from the button press interrupt. But the things in the on start loop only happen, that code's only executed one time when the program first starts. And the things in the forever loop happen over and over again.
Got it.
The things in the button press blocks only happen
When you press the
when you
button.
hit a button.
Right. Okay,
But
I get it.
the curious and somewhat unexpected thing is that when hitting something under the button block, it starts executing that code, but in the background, it's still executing the code in the forever loop. And so
Yeah,
that's why I was getting a happy face in between the blinks that I created on the button.
I gotcha.
So to prevent this from being executed when I didn't want it to be, I had to create what we call a flag and put in an if-then statement so that I could have this only execute if the flag is set to the value of 0. And in my button B code, I set the flag to 1 so that the forever loop cannot execute. And then I set it back to 0 at the end of my operation so that it could go back to showing the happy face.
Got it.
And so that's a and really that's a slightly more advanced programming concept, but a useful one.
William,
Yeah.
the happy face on the start, I erased that one, and it seems like it made no difference.
Have you well, okay. So that's probably because your Microbit hasn't been like reset.
Okay.
So if you're talking about it hasn't made a difference in the simulator, it's because it hasn't been reset. And if you're talking about it hasn't made a change in your actual Microbit hooked up to your computer, that would be because you didn't download the program again.
Okay.
Now down here, launch to full screen, mute audio, toggle, restart simulator. Okay, so the restart simulator is like your reset button. So notice, like, I'm not seeing my other, like, I'm changing my happy face, right? Oh, why did it do that on the start? Maybe it reset. Mine's automatically resetting when I make a change. But at any rate, if it doesn't, then
Yeah,
you could
it did.
button here.
Yeah.
The other thing is if you don't have a pause statement down here, it might happen so fast that you just miss seeing it. Okay, let's see. So everybody, how are we doing so far?
Good.
Pretty good.
Okay. It's I'm still finding it very odd teaching teaching into a computer screen. I'm used to being able to looking at people and seeing the expressions on their faces. That aha moment in their eyes. It's hard to get that through the computer.
Yeah, not much feedback, is it?
Yeah, it's going to be an adjustment for sure.
Yeah.
All right. So I only made this blink on and off twice because I got tired of adding more blocks here. But what if I wanted my blinking to be faster, say 1/10 of a second, and I want it to blink on and off lots of times. You know, not just 2 times. And so without having to put in lots of blocks here, I can use a loop to take care of that for me. So I'm going to get a repeat loop. I'll take my code, I'll drop it in the repeat loop. Since I'm using a repeat loop, I don't really need this second block because I'm taking care of that by using the repeat loop instead. But I do have to. Wouldn't hurt anything having it there, but I don't really need it. By the way, if you have code that you don't want to leave on the screen, you can drag it over here to the left, and then it deletes it. And I don't need to reset the flag to 0 every time. I can do that at the end of the repeat loop. It wouldn't really hurt anything. And I'm going to do this. I'm going to turn it on and off 20 times. Lasts for 2 seconds. All right. So so using a loop to do something lots of times, and now hit button B. And now it's going to blink 20 times instead of just twice. So I wouldn't want to have to like drag blocks over 20 times to code that. So that's where one place where loops come in handy. All right. What if? Well, let's see here. I'm thinking of a good reason to use a. I did use an if then at least, so I used one over here. Okay, so we've gone over loops. We've gone over if then statements. Let me show you a couple other things on the input here. There's this shake command. So if you shake your microbit, you can have something happen. And in the simulator, it gives you a shake here so that you can simulate as if you had your microbit and you shook it, because the microbit's got an accelerometer in it. So on shake, maybe I'll change my face to a more aggravated looking face here. And I'll put a pause after it to try to leave it on the screen. I'll be curious to see if it gets interrupted by this happy face between the face I put in here and the 2 second pause. Okay, and so if I hit shake, and it did it between the pause and the shake, it put the other face in there, not leaving my shake on the screen for as long as I want it to. So again, I'll have to use my flag set the flag to 1. I'll copy this and set the flag to 0 at the very end. And now when I shake it, it'll leave that on the screen for 2 full seconds. So in addition to being able to shake a microbit and cause an event by shaking it, there's a number of other things here with regards to the orientation. So if you have your microbit in the physical orientation of being straight up, upside down, face up, face down, tilted left or right, if you drop it, if it sustains an impact of 3, 6, or 8 Gs, then an event could trigger based on any of those events. So if anybody did like egg drop type activities, again, that might be a good like engineering kind of thing.
Yeah.
Instead of seeing whether or not you break an egg, you could also detect the impact of that fall using a microbit. So I wonder, I haven't done this one with the simulator before. If I make it a logo up, I wonder if it gives me a simulator option for that. And I'm not sure the simulator lets me change the orientation of the microbit enough to test that. Okay, so there's some limits to the simulator here. So I'll go back to just shake. Okay, and there we go. When I shake it, then I've got my different face there. All right. Let's see here. Try to decide what to show you next. So 4 of you have a microbit in your hands, right?
See.
Okay, so
Yes.
since a microbit has a number of sensors on it, another interesting thing that we can do with a microbit is we can use it to collect data, and we can graph that data. And to do that, we need to go to the Chrome store. So has everybody added extensions like Chrome extensions and things?
I
What
haven't.
extension?
Chrome was on my computer. You mean extensions to Chrome?
Yeah. I think this is a Chrome store. Well, no, that says Microsoft Store. I do it so seldom. I kind of forget how I did this, but I'm sure I can figure it out. Here. Yeah, there's a Chrome extension called Beagle Term.
Wait, say that again.
It's called Beagle Term.
Beagle. Okay.
So
Beagle Term.
yeah, so if you can, see if you can find this Chrome extension called Beagle Term. And while you're working on that, if you have it figured out, tell me what you did, and if not, I'm gonna see if I can kind of figure out how I did this back when I did it. I think I clicked on the Microsoft Store, which I think is not what I want here.
I see Beagle Term Google Chrome.
That's what we want. We don't want the Microsoft Store.
And it'll allow me to add it to my computer here?
Yeah, should.
Is the Beagle Term with Beagle Term is serial terminal emulator. That
Yes.
one?
Yes. In fact, I'll look for it. Like if I just go to Google bar, Beagle Term, let's see if that would. So a Google search goes to Beagle Term Chrome, and I'm guessing that takes me to the web, to the Chrome Web Store. And then from there, I already have it, so it says launch app, but from there you should be able to download it or add it.
I'm in.
Okay.
I'm in.
I have a new connection. Anyway.
Okay. So when you launch app, here, let me see if I can think. Okay. I think mine's closed. So when you turn it on, it'll say new connection. And it's assigned mine to COM port 27. If mine's on COM port 3, it doesn't work. So if there's more than one option here, you might need to experiment with the different options and see which one works for you.
Okay, because it is on
Was it?
COM 3.
COM
So
'COM
change
3 might work on your computer. So just because that's not the COM for me, doesn't
Okay.
mean that it won't work.
Okay.
So if we try
Like-
this and it doesn't work, you might pick a different selection or plug in to a different USB port and try it again.
So everything else, bitrate, data bit, all the other data that's just there.
All the
Good to
defaults
go?
should be good. Yeah.
So connect.
Okay. And then we'll just minimize the terminal for now. Right now, it's looking for data to be communicated through the serial terminal between the microbit and the computer.
It says device found.
That's a good sign. We want your device to be found.
Okay.
And so I want to show you this because I think like if you can use this feature and you have a microbit available, it turns it more into a scientific tool of sorts. So I scroll down on my menu to serial, and I'm looking for a serial redirect to USB command. Can everybody see that?
Serial redirect.
To USB, and I have to put that command in my on start block so that it knows that I'm planning on doing a serial.
Serial redirect to USB. Serial. Okay, right here.
It's at the bottom of the serial commands.
Then where? Okay, to start.
Okay, and then I'm going to click on serial again, and I'm going to select the serial right line blocks,
Serial.
the one at the top.
Uh-huh.
And in my forever loop, I'm going to collect some serial data.
Put that in the forever loop. Under the F. Okay.
And I'll be curious to see if the simulator lets us use this or not. Just in case it does, just to make things easier, I'm going to pull my shake block out of here because I'm going to be trying to simulate a shake on the simulator and look at the acceleration data instead of having it trigger an event. And so next I'm going to go over here to input, and there's some sensors on the microbit. There's acceleration sensors, magnetic sensors, light sensors, temperature sensors. I'm going to take an acceleration sensor. This one's looking at acceleration in the x direction. There's also a YZ and then the strength of acceleration, which is a combination of all of them. I'll just leave it as x for now. All right. And so I'm going to download this one. Although before I do, let me show the let me look at the simulator console and see. Export data, copy text. Okay, I'm going to go back. Wait. I'm sorry to say, so far I don't have the simulator doing what I want it to on this one, but I'm going to show you on using my camera what I'm doing here. All right, so I'm going to download. I'm going to call this Bill acceleration test. Download.
Did you just close this? Pop up, complete download?
Yeah, I get annoyed by seeing that every time. Show in folder. And now I'm going to drag this over and drop it on the Microbit.
So, sorry, I was kind of lost. So what you've done is just download, right? And then put it into the Microbit?
Yeah, I just downloaded the file into the Microbit like I did for the other ones. For those of you who don't have a Microbit at home, just bear with me on this part. I'm not sure we can do this example in the simulator. Okay, so I'll close this. My program's running again, and as we speak, it should be sending data to the serial port. So now I'm going to click on Beagle term, and you see on my screen that you see numbers scrolling by.
Yes.
Now watch the numbers. See they're changing. I'm shaking my Microbit right now.
Oh,
Oh.
Now I'll set it down. It'll settle back down. It's just reading numbers again. A little fluctuation in it, but not a whole lot. And in Beagle term, I wish I knew like a stop. Like I don't really have a stop sending option right here. So what I'm going to do is I'm going to unplug my Microbit so it'll stop sending data. So I'll let it sit a little bit. I'll just unplug it to stop it from sending data so it's easier to capture text. And so now what I'm going to do is I'm going to highlight some data. Sorry, my mouse isn't quite cooperating with me. Okay, so now I'm highlighting my data. I'm going to Control-C. I'll eliminate that screen, and now I'm going to go to a Google spreadsheet. I'm going to paste my data in, and I'll insert a chart. I want a line chart because that's a lot more interesting to look at. And there's my data in a Google spreadsheet of the acceleration from shaking the Microbit.
pretty cool.
Yeah, I think that's awesome, and we could likewise be looking at temperature data from the Microbit or the magnetic data.
How do you stop the data again?
Just unplug your Microbit.
There you go.
Yeah.
It's like forever.
So this is this is one of the cool things that you can do that kind of makes this a a tool for science as well as learning about coding and things. There's some code that I'll share with you. It could be that there are circumstances where you want to collect data and like say you want to put your Microbit on your egg drop device and collect data about the impact when it lands. You couldn't drop your computer along with your Microbit. So so we could write code instead that saves that data in memory and then downloads it to the serial terminal. And the code's a little bit more involved, but I think I put it in the presentation documents. Here wait, what's going on here? Every time I hit enter, it's adding new slides for some reason. Is it still doing it? That's odd. I've never seen it do that before. I'm pretty sure I made a slide with this in it. Okay, here we go. So you got a link to the slide presentation, so you'll have this to refer back to. But here's a link to the BeagleTerm app. Here's an article that talks about what we were just doing with logging data, and this should be some sample code showing how to log data when you can't leave your microbit physically connected to your computer. So I don't know if I showed you when if you create microbit programs that you want to share, they have a share button, and then usually I just hit the edit button to bring it up after I've shared it. So there was a link to this code. I hit the edit button, so it now becomes my code, and so here's some code to collect data when you're not connected physically through the cable. Something else I want to show you real quick is there's this little arrow on the screen, and that makes the simulator go away and gives you more space to look at your program. So this I'll explain what this code's doing.
So students can share their program with me. Like I have them make a program, and then they can share it with me.
Yeah,
and then I can
they
run it for others, or
yeah, they just hit the share button,
uh-huh.
Create a name, publish project, then copy the link, and then they can email that link to you or put it in a presentation. When you click on that link, it'll open up the code, and you hit the edit button to fully finish opening it.
Okay. I'll probably come back and ask you more questions about that, but okay, good
Yeah.
to know.
Yeah, that's a good feature. So this made use of the flag concept also. It was named log, but on start it sets this flag named log to 0, so it knows when to be logging data and when not to be logging data. And then we created an array, a variable set text list to empty array. So usually a variable will just hold one value. An array is a list of values. So we can put multiple data points into the same variable name, which in this case is text list, or and store lots of data. And then there's the serial redirect command that I mentioned before. We need to have just to tell it to look at the serial port. And then in the forever command, it's looking at the flag called log, and if the flag's equal to 1, then it's going to list the values. It's going to add a new value to the end of this array. So it's going to look at the acceleration data, and it's going to put that data into that variable list. But right now it's not 0, it's 1, so it's not going to do anything. I mean, it's 0 right now, not 1, so it's not going to log any data. And if we hit the A button, it's going to set the text list to empty array, which means it's going to erase anything that was in this list and make it 0, basically. It's going to make it an empty array, yeah, which means it'll be ready to add new stuff. It's now going to set the log flag to 1 and show this little icon. So now that the log flag has been set to 1 instead of 0, it's going to continually go through, and it's going to take data, acceleration data, and add it to this variable array called list. And it'll just do that indefinitely until we hit the B button. That sets the log flag to 0, which means the forever loop stops collecting new data, and it shows this other icon, a little heart. So we know that we've stopped collecting data. And then finally, if I hit both buttons A and B, it's going to send that data through the serial port where it'll be captured by BeagleTerm. So this is a for loop that's going index from 0 to the length of the array. So say it collected 100 pieces of data. then the array would have 100 different data points in it, or the length of that array would be 100 if it has 100 data points. And index keeps track of how many times a loop has been executed. So the first time through the loop, the index would be 0. The second time through the loop, the index would be 1, and so on and so forth. And then that index number tells the array what position to look at. So the first time through this loop, index is 0, and it'll write serial data from the list and position 0 in the list. The second time it goes through here, the index number will become 1, and it'll write data through the serial port from the list and position 1 in the list. And then it'll go through and the index becomes 2, and it'll look at position 2 in the list and send that data through the serial port and so on. So this is a little more sophisticated programming than what we've been talking about, but I'm hoping I did a good job explaining it.
Yeah, it's there's a lot going on there.
Yeah, there's more going on here, but it's not but it's hopefully graspable.
Mm-hmm.
Yeah, so that's what the code's doing, and I have the link to this code in the presentation, because you may not remember how to set up the algorithms to collect data and then display it. Much simpler. It's only like basically 2 lines to collect data directly through the USB cord when it's hooked up. But if you had to disconnect from the computer and collect data, this is how you would do it. Just one kind of word of warning is if you're collecting data as fast as you can run out of memory pretty quickly. So you either need to put in a short pause so you collect data more slowly, or you need to like turn it on, collect data, have your event. You've got maybe 10 seconds or so, I'm guessing, if you collect at full speed before your data list fills up here. Okay, so let me come back.
So, do they have actual USB ports on Chromebooks?
Every Chromebook I've seen has one. Someone else mentioned that recently too. I mean, if you wanted to plug a mouse in.
Right, you have to. So, okay, I just don't work with the Chromebooks. I only use laptops, so.
Yeah, someone else was asking that same question. I've never seen a Chromebook without a USB port. They don't have they don't have like CD drives or anything.
Right.
But I'm
But
pretty.
you could load something onto it, right?
Yeah, all the Chromebooks I've ever seen at school have a USB port. Without one, we wouldn't be able to program a Microbit on it.
Okay.
Because we program the mic, so it's a moot point in terms of this application.
Exactly. Yeah.
But yeah, they have a USB port. That same question came up when you know how we have some students without Wi-Fi access.
Mm-hmm.
So a suggestion I made was for students without Wi-Fi, because I mean we could make Xerox copies of packets of information and then send those home to the students so that they'd have work to do for class. But it's not quite equitable, because so much of the instruction we deliver these days is digital content with videos and things like that. So I suggested we load USB drives for students who don't have internet, and we could put all the videos and all the digital content on that and send them a USB drive and have them send it back in a week and with their assignments completed. And I think that'd be a reasonable temporary fix.
Yeah.
Okay, we're a little bit halfway through the session. How about if we take like a little like 10-minute break?
Great.
Okay, let's take a 10-minute break, and then I'm gonna run to the bathroom and get myself a cup of tea, and then we'll get back to it. All right, I'll be right back.
Cano, are you there?
Hello? Somebody calling me?
No, I was calling Maria Cano.
Oh, okay.
Scott, what school are you at?
Yeah, I'm at Alvarez.
What subject?
What was that, Ernesto?
What subject do you teach?
Oh, I teach film.
Oh, wow. Interesting.
Yeah, it's a lot of fun.
Yeah, I'm sure.
It's also a lot of work, but it's worth it.
Oh, yeah, I'm sure. Yeah. Well, yeah.
What do you teach, Ernesto?
Math 1A, freshmen, El Salahai.
Oh, that's hard. With those freshmen.
Yeah, yes, it is.
At least you can scare them. The sophomores are harder, I think.
This group of freshmen, yeah, nothing scares these kids.
Oh, that's crazy. Oh, good
Yeah.
luck. Hopefully, we keep distant learning open. You can always read them.
I already told my principals, if I have a misbehaving kid, virtual meeting with the principal.
Ernie,
Yeah.
can you please keep it down, Ernie? I'm trying to focus over here, and you're too loud. Okay, you're way too loud. Thank you, Ernie.
You see that, Scott? No one's minding Ramiro Mata, and he's gotta make himself known.
All right. Well, we'll keep it down so people can work. Okay, bye. Good talking with you.
All right.
Actually, it's not. I don't. You're okay, Rose. It's just that Ernie's voice it's bothering.
It's irritating.
Yeah, I mean, Scott, you're fine. You guys can make all the noise you want. It's just Ernie for some reason. He's just. I don't know about him. He's.
Ramiro Mata, he's my #1 fan. Can't stop talking about him. If you notice, we all started introducing ourselves, and Ramiro Mata started talking about Ernie.
Yeah, that's some funny stuff.
Learning for filming should be easy stuff, right? You can tell them, hey, go out there with your little brother and make up a little film, make it dramatic this time. And next week, let's make it a comedy. Next week, let's make it some adventure.
Yeah, they can be very creative.
Yeah, I like it. I might have to switch.
Hey everybody, how are we doing on time? Is it still break time?
Ready.
Okay. How many? Was that about 10 minutes or do you think people are still like taking their break?
Sounds perfect. We're good. I'm good.
Okay. That's good enough for me.
I'm here.
All right. So I guess, since the focus of this workshop is on physical computing, and although we do have the simulator to work with, it's a little bit limited in terms of what we can connect to the microbit, and one of the unique things about a microbit is that it's a physical device that we can connect to the outside world and have it do things. So I wanted to show you some examples of that, and here I went back and forth on whether or not to show you this one because it's a little bit silly, but I'll still show it to you at the risk of being silly. All right, so my name's William Thompson. It's August 10th, 2019, and I just want to say,
Wait, we can't see it.
fool you. Oh, you can't see it? Oh, I got to share screen. Sorry. Thank you. Okay, present now. I'll go back. Wait. I've got so many tabs open right now. This is ridiculous. Okay, I found it. Okay, so I'll give you like a little backstory on this. I have a friend who's he builds like guitar amps and stuff like as a hobby, and he has for a long time, and so he's always wanted to build like a robotic guitar amp that would change volume. You know, like if he tilted his guitar neck up, he could turn up his amp, and so it occurred to me that since a microbit comes with a tilt sensor in it and it has a radio, I put a microbit on the back of a guitar, read the tilt angle, sent the tilt angle reading to another microbit connected to a servo motor turning a little wheel that would turn the knob on the stereo. So here's so I talked a little bit yesterday about design thinking and developing an idea into a concept and then working through the details of that concept until it became a creation. And a nice thing about a microbit is it's a pretty fast prototyping kind of tool for that sort of thing. So here's a little 1-minute video of that story. My name's William Thompson. It's August 10th, 2019, and I just want to say, don't let the guitar fool you. I'm not a real musician, but I love knobs. So I just wanted to show you this knob and what we set up. I'm hoping you're gonna like this, Ted. All right, here you go. There's, boy, it's hard to see. Okay, there's the knob. Wish I could switch camera views. And there's the guitar. You can do it fast or nice and slow. Once again, not a real musician.
Wow. That took some thinking.
So an example, and for Scott, I just want to say that that was not actually a video, that was raw footage. So so hopefully my future videos will be much better. Okay, so that's one example of you know, taking an idea and then using a microbit to implement it. And someone else here had mentioned I talked in a previous workshop about my gate controller. When my automatic gate stopped working, I just stripped out the electronics from the gate controller, wired a couple solid state relays in its place, and then connected them to a microbit. And I hit a button on one microbit to send a radio signal to the other microbit hooked up to the gate. And when it receives that signal, it flips a pin and triggers the solid state relay, causing the gate to open or close. So another useful thing to do with a microbit. Let's see here. So what I'd like to spend a little bit of time doing is showing you how to connect physical devices to a microbit. And let me switch over. Let me look at some slides so I can show you the actual circuits. Sorry, my slides are not terribly well organized today because some of these relate to turning a microbit into a little robot. I'll show you a little robot real quick though before we go on. Okay, so I got a live webcam here. Here's a little robot that I made with the engineering teachers at my school. So it's just got a microbit on the top. It's got a couple wheels connected to motors. And then this is a little $5 motor driver chip because the microbit cannot deliver enough current directly to a motor to drive a motor. So what the microbit does is it sends a digital signal to the motor controller, and then the motor controller takes power from the battery pack and sends it to the motors depending on that digital signal.
Bill, are you showing your screen on that, or you're just talking about what you have? Because if you're trying to show,
I'm sorry, I did it again, huh?
no, it just happens. It happens.
No,
Thank
no,
you, though.
no, thank you. I forgot to go back to. Oh wait, so there's presenting mode. Okay, and now there's my webcam. So here's a little robot that's a microbit based robot, and I have put the microbit in a little case for safety. I printed these out on a 3D printer, and the microbit is connected to this little called a breakout board to connect these pins on the edge of the microbit easily to other devices. And then I have that connected to a motor driver IC. It's actually a little printed circuit board with the motor driver, H-bridge motor driver on it. And depending on the digital signal sent to this motor driver, it'll tell the motors, you know, whether to turn on or off and in what direction. So little robots are another example of a physical device that can be governed by a microbit. I think I'd shown some of you this this little hand, but maybe I can show it to you like a better view anyhow today. My up down view. Here's a hand that I 3D printed. By the way, Jennifer, you mentioned you have access. You have 3D printers at school?
Yeah, I'm impressed.
And there's a site called InMove. This guy, he created. I didn't draft. I didn't design this 3D hand. All I did was print out parts and assemble it.
Oh my gosh, that's what I was thinking. Is that you? Like, I'm thinking you are a genius.
No, I'm not that smart.
Was I right, Jennifer?
Yeah, he's a genius.
No, not so much.
I'm telling you, once I saw that garage opener, I was like, man, I gotta stay.
I know.
Actually, a saying that has brought me much comfort in my life is, "What one fool can do, so can another." Yeah, so triggering the solid state relay was not that hard, and this somebody else did all the hard work of designing this. I just printed it out and put one together, and then but I hooked it up to a microbit to control the servo motors, And, well, wait a second. Is it going? I'm going to lose my genius status any second here if this hand doesn't start moving.
I think it's very exciting.
You know, sometimes when you have electronic bits, you bump into a wire or something. Well, some of you saw this going the other day, right?
I saw that 2 summers ago. It was cool.
Okay. Well, at the moment, I don't know why, but I'm not up and running right now. I don't know why, because I got the power light on here.
William, when's our next workshop?
I usually do them when they offer the tech workshops. Okay. I'm gonna move on here because my little hand is not cooperating at the moment. Oh, wait, I have one theory. I'll try one thing. Maybe I grabbed a dead battery pack. So okay, there we go. Yep, I probably grabbed a dead battery pack.
How exciting.
Yeah, so InMove, some nice person designed this and he put all the files online for free.
That's wonderful.
Yeah, so if you ever wanted to build one of these, that's InMove is where it's at.
Uh-huh.
Bill, if you can do me a favor, please. There's a finger there that will excite Ernie, and we don't want to play with that because he looks at that hand, and Ernie is a little different. So.
Which finger is that?
Ernesto knows. Mendoza is.
I don't know which finger not to use. I'm really liking my little webcam there.
Yeah, I like it too. Good idea.
Nice to be able to show people stuff.
Yeah. So did you create your own little tripod for it, or?
Actually, wait. Am I upside down here? Get my orientation right. Okay, so can you?
Yeah, I see it.
You see it? So that's a little it's a little phone holding device. I'm not sure what I did here, but I froze up my camera somehow when I grabbed it. My daughter had that. She had it connected to her bed so that she could watch videos and stuff while lying in bed.
Right. Okay.
And then I just borrowed it from her and never gave it back.
Yeah.
I mean, that's
perfect for a document camera.
Yeah. I mean, there's benefits to having kids. You can use their stuff. Okay, so we'll try to hook up some things. I wonder. My focus went a little bit out here. All right, so I hooked up one of these the Microbit to this little connector that allows me to plug it in the breadboard and wire up circuits to it. And I want to show you how to control some different things using a Microbit. So if you order some of these someday, you'll know some other things that you can do with it. Let me just see if I can zoom. I'm wondering if I can change that focus somehow. All right.
Maybe if you go out and go back in again or something. Oh, there you have it. Almost. Yeah, there you go. Almost.
That's better.
There it is. Yes.
Close-up's probably better anyway to see stuff. Okay, I'll try to work with that. All right, so let me kind of go through some of these slides and then I'll find some circuits and show you some circuits. So I'm gonna click through some of these and see if there are any things Anything I forgot to say that I wanted to say? Okay, we talked about those data points. And I want to call your attention to this slide in here. There's some useful things in here, like a diagram showing what these different pins do. So I gave you the pinout for the edge connectors. And
Okay.
there's also links here to some of the online help resources at the Microbit website. Their reference page for commands. There's
Curriculum.
there's curriculum online for the Microbit.
I like it.
So there's a link here to the online Microbit curriculum. Maybe I should go to present and make the screen bigger here. You can also program a Microbit in Python, and so this is the site for programming in Python.
Cool.
And so there's a link. And so this was just a just kind of my viewpoint on coding. I think of coding as a superpower, and as you learn to do new things, you have more superpowers. And so if you yeah, we programmed a button on our Microbit to display a message, but we could have our button doing other things also. So I just want to encourage people to think, what would you have your button do? In the case of my gate opener, I hit a button and it opens my gate. I set up an automatic light because I didn't like the fact that when I walk out to my workshop at night, I turn off my workshop light, and then I have to walk halfway across the yard in the dark before the motion detector picks me up and turns on the light for me near the back door. So I connected a Microbit to a light on my shop and created a little remote control for my shop light.
Cool.
So programming is a list of instructions. We went to the make code site. We did this. We wrote our first program. Okay, we did that. Just in case you weren't here when I talked about it before, I always like to try to tell people about the basics of electricity and circuits. And so if you were here before, just once again, Ohm's law says that current is equal to voltage divided by resistance. And of the three quantities, voltage, current, and resistance, current are the electrons actually flowing through a wire. Voltage is what makes them want to flow. There needs to be a difference in voltage for current to flow through a wire, and the bigger the difference in voltage, the more the current wants to flow. And then resistance restricts the flow of current through a wire. So the bigger the resistance, the less the current can move through the wire. So the relationship between current, voltage, and resistance, being Ohm's law, says that current is equal to voltage divided by resistance. So if you're ever if you're ever like hooking up, a washing machine or something in your house, and you know how much current it is, you can figure out the current. Actually, there's another formula because your appliance will give you the wattage probably, but from that you can get the current and figure it out. Okay, and anyhow, current needs to flow in a complete loop. And if you break the loop with a switch, then current won't flow. There's our edge connector. So I guess the first thing I want to do is I want to show you how to hook up a device to the Microbit. If you didn't have an edge connector, you could take a here. Let me show you on the screen. Where is I want to find an extra Microbit. Okay, here we go. Off. All right, so here's a Microbit. If you didn't have this device to make the pins easier to connect to, they made some of these pins, these pads, extra wide. The 0, 1, 2 pad are extra wide, and then the 3 volt and the ground pad are extra wide. And you could take a small alligator clip and connect things to it that way. And I'm getting into trouble with my phone. Just a second here. I gotta plug a charger into the phone because it's about to die. Okay, there we go. Now the phone won't just spontaneously turn itself off in a minute. All right. So the pins here on the edge are called I/O pins, input-output pins, which means we can connect, outputs can control things in the real world, and inputs can collect data from the real world. And I've plugged my microbit into a little edge connector that has pins connecting to a breadboard that make it easy to connect little circuits to the microbit. And let me, before I actually wire up a circuit, I want to show you how the breadboard works real quick. And I think I have a picture of that right here. Okay, so here's what breadboard does. It gives you all these holes to plug wires into. You could just twist wires together to connect them, but using a breadboard, you can just plug the wires into these holes instead. And there's these little metal clips like fingers pressing together that the wire slides into, and then these little metal clips will touch it. And anything connected in holes in the same row here are electrically connected together. And anything connected to the holes along these side rails are electrically connected together. So it makes an easy way to wire up circuits. And here, I'll go back.
William,
yeah.
Are you my circuit professor in college? I be a general manager at General Electric. Finally, the circuit boards make sense to me.
Oh yeah, you didn't know how the breadboard works before.
How to connect them? Because this explanation, wow.
It's easier when you can actually see what's going on underneath the breadboard. Usually in person, I'd have a breadboard that I broke apart to show you. So let's look at the camera again, and here. So here I have an LED, and I wonder if this was. I worry that my battery is dead here. Sorry, I think it is. Yeah, I have dead batteries. I've got more batteries, but I'm gonna have to grab some. Yeah, my college professors told me I should become a college professor. I told them I was going to teach high school.
The only problem, Bill, is that if you start throwing in some numbers, that's where Erne has a problem. But everything else he's very good at.
Yeah, numbers are tough. Okay, there's some working batteries, and then here's a circuit that's hooked up. So this side is a positive voltage. And and then this row over here is a negative voltage on the other side. So electrons can leave through the negative side. They go through this wire. They go in one end of this LED resistor, LED, through the LED into a resistor to make sure too much current doesn't flow through the LED, causing it to burn out, and then to the positive side of the battery. And now instead of just passively lighting this up, we can control this through the microbit instead. So I can here. I'm gonna move my resistor over to the negative side because I wanna turn this on with the microbit when I put a pin high, and then I'll take this other wire and I'm gonna connect it to one of the pins on the microbit using this little edge connector that makes it easy to connect them. And I wish I had my glasses on. 0. I think this is pin 1 right here. Okay, so I've now connected this to pin 1, and let's hook it up to the microbit and program this light to do something through a program instead of just being hooked up to power. These Dropbox people. Okay, so here I'm just going to go to home and start a new project. Call it LED test. So I always, like I said, I always like to start a program with a happy face, and then to control an output pin, it's not really that advanced, I think. So you come down here to pins, and we take a digital write block, and if I want to select pin 1 because I'm not connected to pin 0, and if I send a 1 to the digital write, that makes it the positive voltage. So that alone would just turn on the light. And here, let's just see if that part works. So here, I'll download that. Show in folder. Okay, and now I'll go back to my little webcam, so you can see it turned on the light now. Something I've been slowly learning as I get older. It's a nice idea to test things in little steps as you go, instead of doing everything at once. That way, if there's a problem, you can pin it down a little faster. So now, what if I want to blink a light on and off? I could now add in a pause. I'm going to right-click and duplicate that first line. I'll turn it off by putting in a 0. Give it another pause. And here, I'll download again. You can see it in the simulation, blinking that pin on and off now. Show in folder. And I always like to kind of start with blinking a light on and off. I kind of think of that as the hello world for physical computing. And so here, I'll go back to where you can see what I'm doing again. Oops, not that. It's not real bright, but see, you can see the light blinking on and off now. Maybe trying to. There we go. Better, right? It's blinking kind of fast right now. I could slow down my blinking in code by. Oof, I've got more than one thing going on here. So I had it blinking at 10 times a second. I'll change this to slow it down a little bit. So if we can blink a light on and off, instead of controlling an LED, we could be sending that signal to the motor controller board to control motors on a robot. We could be sending that signal to a solid state relay to open my gate or turn on my popcorn maker. So sending a digital signal to turn on and off an LED is like a first step, but if we can do that, then we can do a whole lot of other things. And so I always try to impress that on people, that as soon as we can control digital output, there's a whole world of other things that we can control. Okay, so let's look at some other things that we can hook up real quick. I'll leave here and go back to. Well, no, I'll leave it on this right now. So here's a small servo motor. So a servo motor is kind of like what you'd use to control like the tail wing of a plane, or basically anything, you know, it's like a little lever. I'll put the end on it to make it easier to see. I had a larger servo motor turning the wheel that turned that stereo knob on my my guitar controlled stereo. And just to demonstrate good practice while wiring an electric circuit, it's good practice to disconnect power. So on a servo motor, there's 3 colors of wires. There's the brown wire, that should be my ground. There's a red wire, that should be power, and then this orange wire would be the control wire. So I'll connect the ground wire to negative voltage on my board. Let me try to get where you can see my hands. I'll connect the red wire to positive voltage. And I'll connect the other wire to one of the pins on my microbit. In this case, I'll use pin 2. All right. Plug power back in. Trying to set this somehow that we can see it easier. It sure wants to flip over. Okay, there we go. And now we'll come back to the MakeCode site. I'll use a button to turn my servo motor on. And now under pins again, wait. I'm sorry, something's... Oh, there we go. I thought it wasn't coming up. So I'm going to hit pins, and then one of the commands under pins is a servo motor command. So on a servo motor, I'm going to use pin 2 to control it. And the values are 0 turns the motor all the way in one direction. 180 turns that the motor all the way in the other direction. So unlike a DC motor, which just turns continuously, a servo motor receives a certain pulse of electricity, and it turns the servo motor to a given position between about 0 and 180 degrees. So here I'll put a pause statement in, and maybe wait 2 seconds, and then I'll turn it to the other extreme. I'll wait 2 seconds. Maybe I'll use a loop, and I'm going to have it go turn back and forth 5 times. And here's if I don't want it to just stay in this position, because when it's holding in this position, it'll the motor will actively be holding it here, using up electricity. And I want it to when I'm done, I want to just turn off power, so I'm not draining my battery. So when I'm done, I'm going to use a digital write pin, and I'm gonna set pin 2 to 0 volts, and that should turn it off. Okay, so here I'll download this, and if I did everything right, we should see some servo motor action. Okay, I'm pretty excited. Are you excited out there? Uh-oh.
Yep.
Yes.
Okay,
Yes,
good.
very excited.
I'm about to request if you can test it first on the website, but now let's go to the action part.
Oh, I see what happened here. I was like, wait, my microbit's not showing up as a USB device anymore. What went wrong? But it was unplugged. Well, I'm just going to try re-downloading this. Oh, here on the the simulator is also watching it. So see, there it is in the simulation.
Mm-hmm. Nice.
Yeah.
Let's see if we can make it go for real. Servo test. Download.
Unconfirmed.
I don't know what I've done here, but my microbit's not showing up on my USB device right now. I wonder if try turn off Beagle term in case that was confusing it. Complete. I'm not sure. Sometimes everything goes smoothly right away, and sometimes not so much. Okay, so there's my microbit showing up now.
Hooray!
All right, let's try this again. Dropbox is still driving me crazy.
Pop-ups.
Okay, so show in folder. Okay, there's my microbit again. So for the record, I'm one of those kinds of teachers who just doesn't tell the students that the class is over.
Same.
They
I'm the
just
same
get up and
parent.
start to leave.
When I have parent night, I never let them out when the bell rings.
Yeah, right.
I just tell them to tell the next teacher they came from ceramics. I did hook that up to button A, right? Oh, wait. Okay, so I'm dumb.
No, you're
I
not.
wired both positive and negative to the negative side. So this is one of the things you have to deal with when. So there's my servo motor working.
Yeah. Now you have a piezo
Hooray!
speaker on there too, don't you?
Have a what?
Don't you have a piezo speaker there?
Yeah, there's a piezo speaker here. Here, let's pull the
But you're
servo motor out.
You're just not using it.
It's just not programmed in this case, but let's do that. So here I'll add a button B. And there's some music commands here. And so play tone, middle C. I'm wondering if there's I was trying to look for like a tone duration. I remember I did that before, but I forgot. I'll have to check and see how I did that. Okay, so here's a middle C. let's download the program. Servo test. Music. Show in folder. Okay, and I think that's downloaded now. And
That's like a beat.
I don't know why I'm not playing all my other tones, unless oh, I know. Remember that whole issue with the flag?
Right. Everything else is going on.
It started playing the one tone, but then it came back to the forever loop.
Right.
So so I would need to fix that by creating a flag. But but rather than do that, can you hear how it got a little louder?
No.
Can you hear the difference?
We're not hearing it at all.
I just heard like the small little dings.
See, it's easier in person
There.
probably than with the computer microphone.
I can hear it now.
Okay, so you can hear the tone. Now I'm going to move the tube out of the way and tell me if you hear it the same. Okay, so on 3, I'm moving the tube. 1, 2, 3.
Yeah, a little bit.
So
There.
having a tube around it amplified the sound a little bit, like in a musical instrument.
Yeah,
And
like a piece of paper, create a tube like that, like a speaker.
yeah, here
Got
it
it.
is.
Oh yeah, I see that. Sure enough. Yeah.
And so here's an interesting experiment, I thought. Middle C. Here, I'm hoping that's the middle C still, which is 262 hertz. So let's. Oh, my phone's. Anybody have a phone with a calculator on it?
Yes.
All right. So let's do some calculations. The speed of light is equal to the wavelength times the frequency. The speed of light, depending on temperature of air and altitude, things like that, it's somewhere around 340 meters per second, I think. And the frequency of that middle C, I just looked at it, but I promptly forgot, is 262 hertz. A hertz is 1 over seconds units. So what's 340 divided by 262?
1298. 1.298.
Okay, 1.298. So a wavelength is going to be 1.298 meters, and inside a tube on a string likes to amplify, likes to resonate such that you have the nodes of a wave. This is a wave. These are called nodes, and these are called antinodes at the top, where it's higher. A string likes to resonate such that you have nodes at the endpoints of the string. So this would be the first harmonic on a string. You'd get half a wavelength. The second harmonic on a string would be a full wavelength. In a tube, with air, it likes to resonate such that there's a node at an endpoint and an antinode at the open point, which would be the top of the tube here. And so the smallest section of a wavelength that fits inside a tube is 1/4 of a wavelength. So let's move the decimal over here twice for centimeters. What's 129 divided by 4?
Find it. It's 32.25.
32.25?
Yes.
Let me double check my speed of sound. Yeah, it is about 343. 32 centimeters. I'm gonna go with a I'm gonna have to change my frequency to make this a reasonable activity. How about what's 340 divided by 784?
That's 0.434.
434. And 434 divided by 4?
0.108. 0.108.
Okay, wait. 4. I'm 0.108. 0.1. So that's 18 centimeters. Trying to convert from meters to centimeters as I go. So on and what's 18 divided by 2.54 to go to inches?
18 divided by, what was it?
2.54.
Oh, okay. All right. So that's going to be 7.087.
I'll have to double check my process here. I'm not getting numbers in the range that I thought. So I'll just kind of tell you the outcome here because it's taken longer than I anticipated. Here I'll switch to go back to my face. So I somewhere in my setup or calculations, I'm making a mistake right now. I can tell because the ballpark area is not right. But basically, because a sound wave will resonate inside of a tube when there's a quarter wavelength in there. I experimented with this before, and by multiplying that distance by measuring the tube when the sound gets the loudest times the frequency, I was able to measure the speed of sound using a microbit and get very accurate measurements. But at the moment, my thinking somehow is flawed. I'm seeing that the numbers are not coming out in a reasonable kind of way. Gosh darn.
Been a long day.
Yeah, I'm not on my game at the moment. Well, I was gonna hook up photoresistor and a couple other things, but I guess we should probably wrap this up because we're already about 20 minutes over time.
I wish we could meet again.
Yep. Two thumbs up. Did I give you the eval link at the beginning?
No, not yet.
Okay. Let me see if I can find the eval link. By the way, in these okay, here's the workshop evaluation link. And I'll put that in the chat bar. Oh, it
I put a generic one too there, so if they go in there, they can just know
okay.
that it's coding. So if they click that, that should take them to it.
Yeah, because mine it somehow it didn't carry the link; it just carried the text.
Yeah. So if they click on mine, they should be fine. They'll just have to
Okay.
submit another response, and that will do it. Bill, thank you so much. You have a
Yeah.
great evening, and it's always a pleasure to listen to your presentations.
Yeah, I'm glad you're here. And if in the workshop presentation, if anybody wants to make lots of little robots, here's a parts list for making little robots out of microbits.
Cool.
And there's some other circuits here. If you want to power something that draws more current, here's the diagram for how to hook up a MOSFET power transistor to an output pin. Here's a little motor driver wiring hookup for this is a very common motor driver chip. And I included, here's a circuit for how to hook up a photoresistor to a microbit. And a couple other things. So I encourage you to refer back to these slides. Here's one on how to use a sonar unit with a microbit. And we did that one. So we covered a lot given our time. All right. Well, thanks for coming.
Yeah, thank you, Will.
I'll be in touch, Bill. I know I need to get these things back to you, but I'm going to play with them. And if you need them back, I know you'll let me know before I'm done with them, but I will definitely save them for you, and you're going to hear from me anyway.
There's no big hurry. I mean, you could probably hold on to them for the next year or so if you had to.
Oh, okay. We'll see how that goes.
I've got
Thank you very much.
I got a lot of parts sitting around. So if they're getting used, then that's great.
Yes, I appreciate it.
All right.
Thank you, Bill.
Yeah,
Till
thank you.
next time.
Thank you. It was a great presentation.
Yeah.
Bye.
Have a great day.
Thank you.
What's the title of this?
Oh, ya se fue. Shoot.